Cycle, like the hydrological cycle and the atmospheric cycle, is the movement of component parts of that sphere that will result in different conditions in different locations over time. And the cycles, geologic, hydrologic, and atmospheric, are continual. They're not static. There is not one period in time which remains still. And with that, that's easier to see with the atmospheric and the hydrological cycle because we can watch a river flowing by, or we could watch clouds move across the atmosphere, and we know that in a few hours a storm may be coming or the storm may clear up. The geologic cycle is much more difficult because it happens more so on a large geologic time frame. So it's hard for humans to perceive change taking place. We can see change on smaller scales across the globe. And so we can think about things like landslides, which are perceptible to humans. Some landslides occur more frequently than others. So in some locations that are susceptible to landslides, we may see landslides every season. So we know the geologic process is functioning there as a physical condition. Sometimes those landslides will take place in particular locations based on the removal of organic matter, biological processes, securing rock and soil in place. So they have a function, but those are usually less frequent, more intermittent. With that, as well, those are very relatively considered small places on the surface of the earth. A landslide may only take up a few hundred square feet or meters, whereas you relate that to the rest of the planet, and that's a pretty small geographic area. So it's hard to consider that as significant. But if that happens in a place of prominence or importance, such as it disrupts a town or a community, or it disrupts transportation networks that are providing goods and services, that can be significant to the humans involved. So geologic cycle processes have a lot of time consideration and spatial consideration relative to occurrence that we need to consider. With that, the geologic cycle takes three processes into account: physical processes, which we've talked about a little bit already, chemical processes, and biologic processes. Those three processes are fueled or driven by internal and external motivating energy sources. And we mentioned these earlier as endogenic, so internally generated, and exogenic, which is externally driven. Internally endogenic we see as the tectonic plates moving, the tectonic process. So on the surface of the earth, those manifest in things like earthquakes, volcanoes, geothermal vents. We know from the previous slides that this manifests, or the engine of this is the heat in the internal portion of our planet, which then motivates these convective currents in the asthenosphere. The exogenic processes are driven by wind, water, and chemical erosion. And for the great majority of this semester, we've talked about the sun being the motivating energy function that drives wind, drives water through the hydrological cycle, and will drive chemical erosion.